Let's take a look at a couple applications involving polynomial functions. So this first one has to do with the amount of miles of railroad tracks in the US. They looked at data from 1900 to 2011. It turns out, according to this, that in 1916 we had the maximum number of miles and it decreased after that point. So they looked at all the data, they decided that a degree 4 polynomial would be the best fit for that data, most closely model it. So they came up with this really long formula that we're going to use here. We'll talk about how they got that, how we can use our calculators to get that if we have the actual data in another video. But for this one, we just want to make sure we recognize that X here, it tells me, is the number of years after 1900, because that was the initial year of data. F of X is the miles then. So if we need to find the number of miles of track in 1916, what are we going to do? We're going to subtract 1900 from that, get 16. Similarly, in 2015, we'd again subtract 1900, and we would get 115. All right, so those are the two values that we'll plug into this function here. So I'm doing f of 16. Previously, when I did this, I got 246,595 miles. Let's see if that's what I get this time. So grab my calculator and we try to put in these numbers. So be very careful here. Pull it down so you can see it. Negative 0.002391 times 16 is what we're using for this first one to the fourth, plus 0.949686 times 16 again, this time to the third, minus, all right, now I got to move it over so I can see the number here, 123.648,199 times 16, this time squared, and back this way, 4729.3635 times 16, and finally plus 198,846.4097, and enter. Oh, I must have a mistake in there somewhere. Where is my error? So 29, see, this is why these are kind of tricky. 002391 times 16 to the fourth, okay, plus 0.949686 times 16 to the third, minus 123.648,199 times 16 squared. Oh, it looks like right there I missed a plus sign. So here's what you do. All right, so this is good learning experience. So second entry, and that pastes back in. I'm going to go up to where I had my error. Right here, 16 squared, and then I need to put a plus after that. So I go right where I want the plus, second, insert, hit plus, and then I should get the right answer. There we go. That looks a little bit better. All right, so I had done this before, and that's how I found my mistake, but I should have known that there was a problem because the first time I got my number there, did you notice we got a negative? You can't have negative miles of track. So kind of use your common sense to judge whether you're in the ballpark or not for your answers. All right, so for the other one, I will let you do this one on your own, but when I put in 115, I got approximately 133,642 miles of track. Let's take a look at another example. All right, so going the wrong direction on my notes, there we go. Obesity. So the percentage of adults in the US who are obese is increasing, unfortunately, and they found a cubic function that kind of models that data. And the data started in, it says, 2008. Okay, so we want to use this particular function. X is the number of years after 2008, and the answer is the percentage of people who are obese. So in 2008, that would mean X equals 0. That one I can do without a calculator because it'd be 0, 0, 0, 25.494. So about 25.5% of the US adults were obese. What about in 2015? Well, we subtract our start year of 2008 and we plug in then a 7. So if I replace all of these x's by 7, plug them into my calculator, I should get 34.2%. That's over a third of Americans, right? So there will be some problems where they give us the model and we just use that. So the key is always make sure you know what the X stands for, what the answer is, and you can work the problems pretty straightforward. In the next video, we're going to take a look at actually coming up with those models.